Today, our goal is to model with vectors. And so we're going to take real-world situations and understand how they relate to vectors and go back and forth with those two concepts. It's similar to polar in a lot of ways that we worked with before. And so this form over here kind of looks like a polar complex number. And so we're going to deal with that a little bit. The key is to not overthink what's happening. If you can visualize what's happening, you're going to be a little bit better off. So number one says a ball is thrown with an initial speed of 35 miles per hour in a direction that makes an angle 60 degrees with the positive x-axis. Express the velocity vector in the form, in the complex form. All right, so let's draw this out. We're going to think about it in terms of a graph. If you're standing right there, you are throwing the ball 35 miles per hour in a 60-degree line. And so 60 degrees, and then you've got this throw that is doing something like that, where this is 35 miles per hour. The one thing you got to be careful here is it is not an everlasting line. It is not a line that goes forever. It's going 35 miles per hour. Think of that 35 as the magnitude. That is how much force is being thrown behind this ball. And so what we're doing is we are taking that picture and we're relating it to a vector. We want to rewrite that thing in terms of x and y. And so an x and y component eventually is our goal, is to write it like this, or the something I plus something j component. That's our answer. So to do that, we need to know x and y values. Looking at this picture, what can we do with 35 in an angle to find me x and y values? Sine and cosine, exactly what we did in polar. You could make this into a triangle here, and we can use our x, y, and r stuff like we've always been using. All right, so what we're going to do is we are going to take our magnitude to find our x value. We can take our magnitude, take that force of 35 miles per hour, and I'm going to multiply that by cosine of 60 degrees. Think of this as polar. We just did this in polar. In polar, it was this, x equals r cosine theta. It's the same concept, all right? But instead of r, we're talking about a magnitude. It's the same thing, all right? Don't let that confuse you. So it's x equals 35 times cosine of 60. It's 35 times 1/2. What is the x component of my vector going to be? 17.5. That is the x component of my vector. That is how far it's traveling on the x-axis, 17.5 units. Make sense on how we found the x value? Find the y value. You can round your final answer to 3 decimals. Typing this in, it's y equals my magnitude times sine of 60 degrees, because that will tell me my y value. So it's going to be 35 times radical 3 over 2. In a math classroom, we really like the answer 17 square root of 3. You might not like that answer, but it's the exact answer. All right? If we wanted to do that, or not 17, sorry, 17 and a half. You don't like that answer at all because it's wrong. 17 and a half square root of 3. That's the best answer to this question because it's not rounded. But if I do round it at the end, which we're going to do at the very end at no other time today, 17 and a half times square root of 3. We're going to 3 decimals because we always go to 3 decimals, 30.311. There's my answer. If this was a calculus AP exam and you are a week away from starting calculus, if you rounded that to anything else, it would be completely wrong. That is the only acceptable answer. My last class said, oh, well, you take account for rounding errors? No, there are no rounding errors because you can't round it wrong or it's wrong. Be good. Questions with that one? Make my x value, it's right, yeah. My y value is positive. That makes sense. That ball is getting thrown into the first quadrant like we know it should be. Resultant force is a physics concept. It says when 2 or more forces act on an object at the same time, the resultant force can be determined by adding the individual force vectors. Or in other words, if you have 2 forces acting on an object, if you add those 2 vectors together, it will tell you the new path of the object. an airplane maintains a constant airspeed of 500 miles per hour headed due south. The jet stream is 80 miles per hour in the northeasterly direction. Express the velocity of the airplane relative to the air and the velocity of the wind in the jet stream. All right, so here's what's happening. Let's draw a picture of this. This is just like what we did with Garrett, and we pushed him around a little bit. You've got an airplane. Which way is it traveling? South, okay? You don't even need to make it an XY graph. We just automatically kind of make it that way. You've got a plane that is moving this direction. It doesn't matter where it started, but it's going that direction, and it is traveling at 500 miles per hour. It's got a big old engine that is pushing it 500 miles per hour that way. You also have a jet stream. There is wind when you fly an airplane, and this is really true. If you go cross country, you know that your flight can go way faster or way slower depending on what the wind is doing. I'm doing 500 miles per hour south. You've got a wind that's going 80 miles per hour northeasterly. So what angle do you think my wind is going if I'm going northeasterly? 45. And so I've got a wind that's attacking this plane at 80 miles per hour at a 45-degree angle. In the end, which way do you think the plane is going to end up? In which quadrant will this plane end up moving as we work? The fourth quadrant. It's trying to go south, but that 80 miles per hour is going to push it a little bit offline. Okay, it's not going to be quite going the same direction. Is the plane going to be going faster or slower if you have a 45 mile per hour wind going back at it? Slower. That was a bad way of saying that, but it's slower, right? It's not going to be traveling. What if that wind were going this direction? If that wind was traveling southeast, would the plane end up going faster or slower? It'd be faster because you got a little bit of a tailwind on it, all right? But because it's got a headwind, because it's going in the opposite direction that you're going, it's going to slow you down. And so our job eventually is going to be figuring out what angle is that plane really traveling in and what speed is it going to go now with that jet stream, all right? But we're going to talk about it in terms of vectors. And so the first thing we're going to do here is we're going to find vector of the airplane vector. And we could do some fancy math for this, but the vector of the airplane is really simple. How much is that airplane, with just the airplane, with nothing else, how much is it traveling left and right? Nothing. It's not traveling left and right. That's not the goal of this airplane. The goal of the airplane is to go due south. And so there is zero force on that airplane traveling left and right. But that airplane is traveling due south. How much is your vector going up and down? 500. And which way is it going? Negative 500. That is the vector of the airplane. I didn't go left and right. I was trying to travel 500 miles per hour straight south. That is a direction. It's going south with the magnitude built in there as well. Technically, what did I do to figure that out? I took the magnitude and I multiplied that by cosine of 270 degrees I plus sine 270j. You don't have to do that. You can know those things. And we took those two numbers, we multiplied it out just like we did up above with the throwing the ball. But we could figure that out a lot easier by just using our brain. Everybody good with that concept? Let's find the vector of the wind now. So the vector of the jet stream. For this one, we probably want to use an equation. What is the magnitude? What is the force? What is the strength of that wind? 80 miles per hour. I want to know the x and y components of that vector. And so we're going to take that 80, and we are going to multiply that 80 by my angles. So my angle of cosine of 45 degrees I plus sine 45 degrees J. Go ahead and figure out what those values are. If I wanted to be truly mathematically sound, if I wanted to be a hardcore calculus teacher here, I would say don't round this at all and don't use your calculator. Because what is cosine of 45? So it's 80 times square root of 2 over 2. And so that is the same thing as 40 square root of 2. That's the non-rounded version, 40 square root of 2. And my y value is also going to be 40 square root of 2. I'm going to come off my high horse a little bit and just get an actual answer here. And so 40 square root of 2 is going to get me this number right here. I will not suggest this in the future, but let's round it. 56.569. 56.569. That is the wind. It is traveling 56 miles per hour to the right, 56 miles per hour north. It's moving my plane in that direction. Find the velocity, V of G, the ground velocity. I don't like that phrasing, but apparently that's what they use, of the airplane relative to the ground. Or in other words, you are finding the velocity of your airplane vector plus your wind vector. What happens when you add those two vectors together? That is what we're trying to figure out here. So, what do you think I need to do with my airplane vector and my wind vector to find airplane plus wind? Add them together. And so my velocity of my airplane plus wind is going to be 0 plus 56.569. That's going to be my x value. My y value is going to be negative 500 plus 56.569. Negative 443.431. Everybody good with that part? That was easy. All it was taking my x's and my y's from my above and adding them together. So cool, this is the direction that the airplane is traveling. That's how much it's traveling on the x component. That's how much it's traveling on the y component. But that doesn't mean a lot to us yet. Let's rewrite this stuff and find the actual speed and direction of the airplane. So I want to know back in miles per hour and back in direction. Which way is this airplane going? And so think about this. I am giving you the x and the y of the airplane. You want to find out the magnitude and the direction, the angle that stuff is traveling. Take a second with your group and try to brainstorm. How can you figure out, given x and y, how can you figure out the magnitude and the angle of that plane? Cool. Glad everybody's on the same page. Find the actual speed. I've got x and y. I'm trying to find the magnitude. What can I do with those things? Pythagorean theorem. I'm going to take 56.569. I'm taking that value. I'm squaring it. I'm going to add that to my y value, negative 443.431. I'm going to square that number as well. When I take those two things and I square them, I'm going to get a value that I want to square root. I'm doing Pythagorean theorem. I know the x, I know the y. Putting those together will get me my magnitude. So 56.569 squared plus 44.431. No, that's wrong. 443.431. We get that number. We're going to take that number. We are going to square root it. Oh, no, I hit weird buttons. There's going to be my answer, 447.025. That is in miles per hour. That is the magnitude of VA plus W. That's the speed of that plane. Does it make sense that it's less than 500? Yeah, it's pushing in another direction. And so we understand what's happening there. It's slowing it down. That is my velocity. That is the speed. How could I figure out the angle? They told me X and Y, and I want to get an angle from that. What can I do? Yeah. Tangent of theta is equal to y over x. Find out what theta is. We're typing that in. We're trying to figure out those numbers. So I did inverse tangent of negative 443.431 divided by 56.569. I typed that in. I hit enter. No, I don't. I hit a negative sign, which is going to throw everything off. Let's try that again. Delete that. There we go. Hit enter. My actual answer is negative 82.729 or 0.730. Negative 82.73 degrees. Does it make sense that my angle that I ended up with was negative 82 degrees? Tell your neighbor why that makes sense. The plane was going south. The wind was blowing northeast, so it makes sense that my flight is going to be a little bit off track and it's going to be kicked into the fourth quadrant. Giving me an negative 82 degree angle makes sense to us, or at least it should. Questions on how I found out those two values? Cool. Flip it over to the backside. Let's get to the tough one. On the backside, we are trying to figure out this setup. We've got this box. We've got a box. It is being hung above the ground. My computer's being super slow. There it goes. You've got this cable system. You already have this picture drawn. You've got this box. It is 1,200 pounds. You've got one rope holding onto it this way and another rope holding onto it that way. This rope has a 30-degree angle. This rope has a 45-degree angle. It says a box of bananas is 1,200 pounds and it's being suspended by two cables attached to the ceiling. What are the tensions in the two cables? When it asks for tensions, it is describing the magnitude of the vectors. How much strength does each rope have to hold in order to keep that box from moving? That box right now is standing still. It is being suspended in the air. And so it is in equilibrium. It is in static equilibrium. The object is at rest. The sum of all the forces is 0. It's not moving left. It's not moving right. It's not moving up. It's not moving down. It is standing still. How many forces are acting on that box? It is not 2. It is 3. You've got one force that is trying to pull that box that way because it's being attached to the ceiling. It's pulling it that way. I'm going to call that force A. You've got another that is going to pull this thing this way. I'm calling that force B. What's the third force on this box? Gravity. You've got another force that is taking this box and pulling it down. Let's call that force C. All three of those forces have to be in equilibrium. They have to cancel each other out. It's not as easy, though, as one going up and one going down because they're moving at angles. And so what we're thinking about here is that the X and Y values of these forces need to cancel each other out. So let's write this out a little bit here. Let's talk about force A. Force A, it has some tension in that rope. I don't know what that tension is. Let's call it A for right now. All right, and when you think of A, it is a magnitude. That is the strength of the rope. How much is the tension pulling on that rope? Okay, that rope, that cable is being pulled left and up, left and up. And so how could I figure out the vector that goes along with that rope? Just like we did on the front side, we're going to do cosine of my angle. It's pulling it left. What angle should I use here if I'm pulling it to the left? Say it. Campbell, you want to say it? Not, you're close. One what? 150. It is a 150 pull. Why is it 150? It's a 30-degree angle. It's a 30-degree angle from the box, but which way is it going? It's going left. And the only difference between 30 and 150, 30 cosine is positive. At 150, cosine is negative. We want it to be negative because it's pulling it to the left. And so cosine of 150, comma, sine of 150. That's what it's pulling for force A. You're pulling left and up in that direction with this mystery force. That's what we're trying to figure out. Our second force, force B. You've got some mystery force. How much strength is that rope holding? We need to figure that out. And we're going to multiply that thing by its vector. Well, its vector is going to look like this. Its vector is being pulled to the right, cosine of 45 degrees. And it's going to be pulled up, sine of 45 degrees. There's my second vector. My third vector is a little bit easier to write. That is gravity. I don't really need to talk about f of c times the things because I can just figure it out. What is my third vector going to look like? How much is it being pulled left and right with gravity? 0. How much is it being pulled down? Down 1,200. Technically, we could have written sine of 270 and cosine of 270, but it would have just given us this vector in the end. I just went ahead and sped up the process. Questions on those three forces? If this thing is in equilibrium, the forces are going to be equal. So let's write this out. Okay? And so you're going to have the force on the x-axis. So the stuff that is pulling you left and right. They need to be balanced. What are the two numbers that are pulling it left and right? The cosine values are, right? The things in the x position. And so this guy is pulling us left. This guy is pulling us right. In order for it to be balanced, I need to take, and I would have to distribute in those values, a cosine of 150. That's going to be a negative number. It plus b cosine of 45 degrees. Do I need to add anything with the part with force C? It's 0. What does that need to be equal to when I solve it? 0. It can't be moving left and right. That box is standing still. It's 0. So those two forces added together are going to get you 0. The other force we have to worry about is going up and down. The up and down forces need to be balanced. Or in other words, our vertical pull. And so A times sine of 150 plus B cosine of 45 plus negative 1,200 or minus 1,200, however you want to write it. It's the same thing. Minus 1,200 because I've got a third force, and all of those need to be equal to 0 because it's in static equilibrium. That thing needs to be equal. That thing needs to be equal. How many variables do you have here? You have two variables. You got a variable right here with A and B. You got a variable right here with A and B. You got two variables. You got two equations. We are doing elimination, okay? Substitution elimination. It's our job to solve it. I'll get us started here, and then I want you to solve it. So let's take this top equation. If I'm taking this top equation, let's solve for a letter. For example, A is going to be equal to, well, let's do A cosine of 150 is going to be equal to B cosine of 45 and negative because I subtracted it over. Then I'm going to divide by cosine of 150. Divide by cosine of 150. A is going to be equal to, in my calculator, I'm taking that and plugging it in, negative cosine 45 divided by cosine of 150. I type that in, I hit enter, I get 0.816. And I'm going to go one extra decimal here. How do I want to do this? Let's go one extra decimal. Because I'm going to round here, I'm going to go to 4 decimals. Okay? If I go to 4 decimals here in a minute, when I come back to it, it'll be better. The more decimals you go, the better it's going to be. And so I'm going to leave that as 0.1865. That is what A is. Make sense on what A is. Now that we've got this, we are going to take this and we are going to substitute that in for A and solve. Solve. Find A, find B, go from there and get an answer. Go. If I want to keep this mathematically correct. If I don't want to round this, I'm going to use my calculator to get me the right answer. And so I'm taking this 0.8165 number, and yeah, we just rounded it, but I don't need to. It's in my calculator. So I'm just going to go up here, and I'm going to select that number, and I'm going to multiply that number by sine of 150. If I do that, I get this 0.408 number. So I'm going to round it right this second, but I'm not really rounding it because I'm leaving it in my calculator. This number plus b sine of 45. So I could do sine of 45. It gets me that answer right there, this 0.707 number, b. But I really don't want to round them. And so what I'm going to do is I'm going to take this number plus that number up here, and it's going to get me a number that's not rounded, because if we round them, it's going to be off. In calculus class, we can't round numbers in the middle of problems. It gets me that number right there, 1.115b. And it's going to be equal to 1,200. What do I need to do to actually get my answer? 1,200 divided by that value right there. If I take 1,200 divided by that value, it will get me my actual answer to this question. How much strength is being pulled on the B rope, on force B? 1,075.891. Now I can round because I'm at the end. My B is equal to 1,075.891. What could I do to find A? I'm going to plug it back in. I'm taking that times that B number, which was up here, this 0.8165 number. I'm plugging into this equation right here. It gets me my A value is 878.461. Are those two numbers, when you add them together, is it equal to 1,200 pounds? Doesn't have to be. Because they're pulling at weird angles, they're not going to be the same. Don't make you think that they need to be. If you pulled something at an angle, it's going to pull it a little bit differently. It's a challenging question, but it's a good one. Make sure you know what you're doing with that. Easy.